Latin square designs are a way of saying how factors can affect the outcome of an experiment using multi-factor analysis of variance, aka ANOVA. They are used when you are dealing with an experiment of three factors. Literally, they are grid-like tables that we construct in a certain manner so that we can isolate the effects of a specific factor out of the three. The rows and columns are assigned numbers, and then the third factor are assigned letters from the Latin alphabet. The letters are where the Latin square designs get their names. Each row and column can only have one of each factor in it. This is done to ensure that each square is a unique combination. Latin square designs are used to control for variation in the first two factors. The value of the level of the third factor is completely determined by the other two factors. For example, say you have an experiment with four variations of the three factors. Factor 1's variations are assigned numbers 1 through 4. Factor 2's variations are assigned Roman numerals 1 through 4. Factor 3's variations are assigned letters from the Latin alphabet A through D. Each square in the grid represents a combination of the three factors. I highlighted three random squares to show how they are different combinations of the three factors. Note that each number n of variations of the rows, columns, and letters are the same, with the total combinations equaling n squared. To ensure quality results, it is recommended that the squares are assigned at random. Here's a possible engineering example. Say if you were attempting to hit a certain range of electricity generated by an alternating current generator. According to the Biot-Savart law, two factors that would affect the resulting magnetic field created by the current in the wire are the current in the wire and its radius. We can ignore mu0 since it is a constant. Applying Ohm's law, we can replace current with the ratio of voltage divided by resistance. This gives us our three factors for the Latin square design: voltage, resistance, and radius of the wire. Latin square designs use the equation involving the sum squares of SST equals SS row plus SS column plus SS letter plus SS error. You can construct an ANOVA table using the Latin square designs. In the table, you can use sum of squares that correspond to each row, column, and letter. In the table, the sources of variations are the three factors, and each have their respective sum square. The degree of freedom for each factor is n-1. The mean squares are simply the ratio of the respective sum square divided by the degrees of freedom.